Number 4, water flows as two free jets from the T attached to the pipe. The exit speed is 15 meter per second. If viscous effect and gravity are negligible, determine the x and y component of force that the pipe exerts on the T. So here in this situation, you need to understand what is the viscous effect. So viscous effect means the no slip condition effect in moving fluid. So we just assume, normally if we assume that no slip condition occur, so we understand that there is a molecule stick very hard on the surface, and then it create the velocity profile. So we assume that this idea is not applied here, so we just assume that all the velocity is the same. So we could just easily calculate the average velocity. So, and then the gravity negligible means, again, in your Bernoulli equation, it is okay for you not to count the value of z1 and z2, because the height is maybe too small, and the potential energy is actually can be neglected in this calculation. Okay, so here you have one inlet and two outlet. So, and then your inlet here, it's still moving inside the pipe. So however, for outlet here, so it going freely to the atmospheric, so the pressure is 0. So this is the diagram that you could draw. So this is the direction of N. Okay, it must be going outside. So, and then this is the direction of pressure, so it must be pushed into the control volume. So, and then we could calculate the velocity here. So the very basic one is, I hope you could understand this one, Q1 is equal to Q2 plus Q3. So the idea is very simple. So this is the inlet, so means that the inlet here must be equal to the outlet at this one and outlet at this point. So this is the basic idea. So, and then you could calculate that the velocity v1 is equal to 12 meter per second. So, and then we could compare using the Bernoulli equation. So we could get the P1 is 40,500 Newton. So because P2 here is equal to 0, it is released to the atmospheric. Okay, to develop the Bernoulli equation here, what you need to understand is you need to imagine how the fluid flow. So means that because we have a two outlet here, so you cannot say that Bernoulli at this point is equal to Bernoulli at this point plus Bernoulli at this point. So you cannot easily assume like that, because Bernoulli equation is actually based on the streamline. So you just imagine you have one molecule here. So this molecule will flow into this outlet. So means that the Bernoulli equation for this one is equal to the Bernoulli equation for this one. So or you just imagine that you have another molecule. Okay, let's say you imagine you have another molecule here, and this molecule is travel to the second exit here. So this energy is equal to this energy, so means that you could make equation of Bernoulli equation from inlet and outlet. Okay, so let's say we compare the velocity here, so we could get the pressure is 40,500 Newton. And then to calculate the force at x direction, so we just use this equation. So we substitute everything, so we could get that the Rx is negative 72 kilonewton from left to the right. So, and then you need to explain what is the direction of that force. And then for y direction, so, and then the value of reaction force on y direction is 67,500 Newton.